Right, okay, before I get started, this is quite an interactive thing, so what I want you to do is get out your phones and laptops and whatever, visit this URL. There's already 3 people there. That's what that counter is, people. Cool, yeah, I actually gave this presentation last night, but the difference between today and last night is that I'm sober today. It was like, I was like shining my laser in people's eyes and stuff. It was kind of dangerous. So yeah, we're all safe. And there's a lot of demos in this, which is, as you said, but yeah, so there's things that could go wrong. So I'm sorry if that happens, and yeah, try and be on my side. Cool, right. Hi. I love web pages. Cool. So hi, I'm Ben. I'm from Oxford. Well, I'm from Scotland originally. I live in Oxford. I work at a company called White October, and we are a web agency, and we host events like JS Oxford, which I help out in quite a lot. And yeah, I'm down for the day, which is nice. And my talk today is about the multi-device web. And so multi-device, so when we're interacting with technology, we quite often do it through a single device. So when you're visiting a web page, you're physically interacting with that one single device. Whereas actually you can have several devices around you that could be part of that interaction. And so the multi-device web is about utilizing those together in close proximity and to create one interface with technology. And the web's really important here, really great here, because the web allows you to kind of distribute content to a variety of different device types. And so by combining those various devices together, you can do some really interesting things. Cool, we got 34 people. Right, so as you mentioned briefly, the bad news about this is it's not actually about Meteor. Yeah, I'm a kind of pre-adopter of Meteor. But there's also good news, which is it is kind of about Meteor. So what I'm going to talk about is about how to kind of challenge the way that we build web apps, and that's from what I know of Meteor, which isn't a lot. It seems a kind of similar kind of aim. So yeah, I guess we can get started. Right. So I'm going to make this a bit bigger. Cool. So we've got 4 different sections that we'll cover really quickly. The first one, capabilities, so the kind of, by having several devices with different capabilities, what those are and how we can utilize those. Transport, so that's a kind of hard thing, is getting data from one to another, which Meteor is really useful for. And we'll cover some of those. And then the types of interfaces that we can build by considering devices in close proximity to each other. And then the future. And yeah, there's tons of demos all the way through, so that's good. Right, capabilities. So as I said, the web's really nice because it allows us to put our content onto devices that are very different. And yeah, it's a great platform for that. And each of these devices have different physical capabilities and ways that you can physically interact with them, and also different features like kind of touch interfaces versus keyboards and stuff. And so the 2 examples we're going to cover is laptop. So this is you can use this to surf the web if you want. You've got the touchpad on the bottom, which you can move a cursor around and point to stuff. And you've got a keyboard, which you can, this is all pretty obvious. But yeah, you can use this to visit websites and interact with them. But another device, so I've got my phone here. And this is also, you can use this to access the web as well, but it's a very different type of device. So instead of having a touchpad to move a cursor, you can actually just touch items around on your screen. So there's a much kind of closer to your interaction by doing that. And because there's a screen on this, I can put up a keyboard and I can start typing stuff. And also, as well as touching, I can now move things around just by dragging them with my finger. And it's a very different way of interacting with it. And I can do multi-touch gestures. I can gesture out, rotate around, pinch in, slide down. Oh, open tabs. Slide down, slide up. And I can really kind of get involved with this device in a very different way. And not only that, but this device has got very different physical properties. I use this as a mobile device. I move around with it, so I can access my geolocation in it. So that's the latitude, longitude, and the accuracy is 30. and then getting more accurate as that gets a better gauge. So this I can know where I am in the world through the web browser. It's also a movable device, so this is the orientation of that device. So as I kind of move it around, so in space, you can see what direction it's pointing. So that first parameter is the compass. So you can see as I turn it around, it jumps up when it's north or something. I don't know. And motion as well. So the actual kind of moving the device around. And this is unique to this style of device. Like, it doesn't really matter. You don't really want motion detection on your laptop so much, unless you're like throwing it places or something. And what's nice is that these two devices can both utilize the web in their own way, but you can. The nice thing about the web is that you can actually serve that content to both devices at the same time, even though they're very different. So I can actually, this presentation is all HTML and CSS, so I can load it up on this phone here. And this phone is physically quite different from my laptop. So instead of pressing a button to change slide, I can just slide it up. And because these two are connected, I'm able to kind of switch the slide on that device here, with a touch gesture, which that device doesn't actually have. So by kind of linking those together, I'm able to interface with the web app in a different way. And here we've got a file chooser. And if I was to choose that on my laptop, it would open the file dialog. But I can do it on my phone, and it actually opens the camera, right? So what I'm going to do is if everyone wants to put their hands in the air and wave, brilliant. Oh, I'll cancel and get you in. Sorry, this is taking longer because of Ollie. Cool. So as I save that file, then that's able to stream up to that device there. So what's nice about this is that we're able to, this has got very different physical properties. So it's got a really good camera, and it's movable, so I can actually get it into a place to take a better picture. Whereas this computer is connected to that massive projector. So we're able to kind of combine these physical properties of these two devices by using the web to share their capabilities between each other. Yeah, I think that's what I wanted to say. Cool. I've not got any code examples, which is kind of good because they're not Meteor code. But I'm going to briefly say the libraries that I've used, and that will be cool. You can read up on them yourself. So that uses Peer.js, which is allows you to create a connection between two. It's like a WebSocket style connection between these two devices, and we'll get into that in a bit more detail later. And Binary.js allows you to kind of send big blobs of data across WebSocket style connections, which is really cool. And they're kind of related projects on GitHub. Right. Okay, so you want to get your phones out now on that page. We're going to talk about browser features. So we've talked about the physical features between these two devices, but also each of our browsers have a different kind of feature set. So these are some of the features that you can look up just by going on the window or document. So we've got application cache, so the offline stuff, CSS animations, and touch interfaces, web workers. All these you can find by going document.webworkers and if they exist or not. And when you visit that first URL, we captured all the features of each device in the room, and you should be able to see them on your devices now. And also, this is all the devices in the room. So not one person here has a battery API. Yeah, a bad one. And yeah, we've got some quite interesting things here, device orientation and motion, which are different events, but everyone who supports one supports the other in this case, and one person doesn't have orientation events. Another person. Cool. So yeah, full screen API. You can see this chunk along here, and that's really interesting because the people, this is arranged by when people join. So people who join first have better full screen APIs, and that's because people who join first would likely to be on laptops, so they can type in the URL faster. So that explains this kind of chunk of that and lack of touch events here. Yeah, cool. Right, so what we're going to do is we're going to concentrate on a few of these, so 4, which are covered a little bit. So geolocation, so finding your coordinates, touch events, being able to actually physically touch your screen, orientation, turning it around, and WebRTC. Who here has heard of WebRTC? Excellent, cool. Yeah, so being able to negotiate a peer-to-peer connection between browsers and also able to stream media like audio. So on your phones, you should see sliders for each of these. Do you see those? Yes, cool. So what I want you to do is put in your experience with each of these features. So on the left, if you've never touched it at all, and on the right, if you know it very deeply or whatever. Cool. Right. So yeah, I think I'm kind of like middle of the road on these, maybe slightly up on WebRTC. I've hacked around with that quite a bit. We've got a bit of a gap in the middle. That's kind of cool. Right. Is that everyone cool? Right. Okay. So that's experience. We're going to think about how awesome these are. Right. So what kind of impact you think these make in the kind of future of future past whenever the internet. So great. Yeah, we think things are awesome. Yeah, kind of. Not device orientation. So yeah, again, there's a gap. Right. Cool. So yeah, this is again like yeah. I tend to be on the awesome side of thinking things are great, but whatever. Is that everyone done? Cool. So now that we've got those two data points, we can actually plot those together. So this is awesomeness versus experience upwards, right? So I kind of think of this as 4 different quadrants. So the top right one is like where you think you're stoked by something and you're also very proficient at it. And that's where you can create some really good stuff. Yeah, I like this line of awesomeness. That's cool. That's really nice. And across down here is where we think something's awesome and we haven't touched it that much or we don't know it that well. And it's really easy to kind of move from down there to up at the top. And because if you're excited and think some stuff's awesome, then you can get engaged with it and move yourself forward. I'm glad this is kind of empty. It's kind of, you know something really well and you think it's rubbish, which is like a kind of cool thing. Device orientation, yeah, cool. And this place is fine as well. It's like you don't know you don't know how something works, and you don't know that it's awesome, so you could go anywhere. So I think I like to try and think of things like this. Cool. Right. So for that, for the feature testing, I don't know who's modernizers. Cool. Yeah. So yeah, that allows you to kind of do some really good checks and really simple ways to make your interface more appropriate to particular features or lack of. And for the sharing from my slides to your phones and your votes back to my slides, I'm using PubNub, which is a kind of like a good publish subscribe channel thing, which is really, really neat. So that's how I use it, slides. And also you can have a state for each user. I don't know how that fits into Meteor, but yeah, it's kind of cool. Cool, and then lastly in this section, so we've talked about features there, we talked about browser features, and this is about the multiple device web. And the web doesn't actually start at browsers. Browsers are like the end of it, like the presentation layer, where what's underlying is really powerful and great. And there's a whole different type of device. So this part sometimes doesn't work, but this thing here, yes, this is a sensor tag. So it's it's not a web browser. It doesn't even have a screen, right? And it's a Bluetooth low energy device with like lots of different sensors in it. So for instance, we've got buttons, and I can press these 2 buttons off or on, and it updates. And what's cool about this is like, so I'm touching these buttons and changing the contents of a div, which is I like that. And yeah, it's also got other things like, so it's got, you can detect temperature on it. So these first one's ambient, the other one's an infrared temperature. So I can point it at like my water, and you can see that that's colder than the outside. So it's like, We've got gyroscope, like a lot more basic than my phone, but it updates when you move it around, and a magnetometer, which kind of tells you about the magnetic field around this. And it's got some more, but you can only activate 4 at the same time. But my point with this is that this is a very different kind of device than the ones that we would usually interact with the web with. But by connecting to this and exposing it using web technologies, we're able to kind of make it part of the web and make it part of our domain as people who work with the web. So I think that can be quite powerful. And Jenny from the ODI said this, which I really like, which is we make a mistake if the web is only HTML. We think of the web as only HTML. And yeah, the web's a lot bigger than this. It's about endpoints. It's about HTTP. And I think it's worth remembering as web developers. Cool. Capabilities over transports. So as I said at the start, when you've got several devices together, one of the kind of key problems is how to kind of keep those two devices in sync. And this is where, I guess, my limited knowledge of Meteor, that's what it's good at or whatever. Yeah, oh, fuck, that was terribly said. All right, okay. Yeah, so the problem with the way the web works and sharing information between devices that you come up against, because it's all request response based HTTP, you can hit this problem that, so this browser here has made a request up to a web server with its data, but this second browser that's sitting there doesn't know that request has been made, so it doesn't know to make another request to go and update its version of the world. And there's a few ways to get around this. So you've got polling, where the two browsers continually re-request the data and see if it's updated, which is obviously kind of bad most of the time. Long polling is a bit of a, that's where you poll, the server holds onto it, and then waits till something's changed before it comes back, which is slightly better. WebSockets, which allows you to create a duplex connection to the web server, and so you can just send messages, proxy them through that web server. And I think that's how what Meteor is. Yeah, SockJS? SockJS. The extraction of the WebSocket. Cool. And that defers to long polling if it's. It will fall. Yeah, cool. So yeah, Meteor links. Right, okay. But the problem with that is that it's always got to go through a server, right? So like your messages have always, despite you having the fastest internet connection, if your server's in America, then there's going to be that latency of syncing up those two devices that are right next to each other. And that's where WebRTC comes in, because it allows you to negotiate a direct connection between those two devices. And so you kind of, if your server's in America, maybe your messages only just go through your router locally. So it's very useful for having devices right next to each other. And what we're going to do is we're going to take a little bit of a look at these different transports. So I'm going to send messages from my phone to my laptop, and I'm going to do it over these 4 different channels. So we've got WebRTC in black, so that's directly between those two devices. WebSockets, so through a server, coming down the other side to the other one. Yeah. Long polling as well, so the server that holds on to the request until something's changed, and then a delayed long polling as well, so to kind of emulate a slow server at some point. So if I just like start touching on here, you can see these points coming in, right? And you can see these top 2 are kind of streaming, and the bottom 2 are coming in chunks and little packets. And yeah, so, and you can see the red one, the packets are a lot chunkier. So yeah, that happened. So yeah, the data all got through. They all kind of got synchronized up. But these 2 were streaming, and the black one was slightly faster. So we can actually, so that's kind of hard to see. So what we can do is we can visualize this by using the z-axis for time. So if you imagine those points as I'm drawing them are coming out at you. And what we can do is we can view it along the z-axis as well. So this is like, yeah. Thanks. So yeah, this is like a graph of time and stuff. So you can see here the 2 streaming ones are ahead, and smooth, and you can see the difference between those long polling and how they get bigger. And the reason you get more, so there's a bigger message in there, and the reason for that is after the response has been satisfied and a new request has been made, more data has appeared on the server, so it's got more stuff to send down. Yeah, and another interesting thing is that green spot here at the start of the blue, and that's so the first long polling event that came through at the same time as WebSocket. So when you've got sporadic one-off updates that happen every couple of minutes, then long polling is totally fine. It's as fast as WebSockets. I'll show you something I realized the other day. I can actually redraw this in that mode, which is kind of weird. So you can actually see as they're coming in those packets, which is kind of trippy. It's kind of really satisfying to do. I was doing that quite a lot. And an accident as well. Cool. So for those, I use Meteor.js, which I mentioned before, allows you to create that WebRTC connection between two different devices. Socket.io or socks. They're not the same, but they're, yeah, whatever. You guys, right, and yeah, that allows you to do the long polling and WebSocket stuff. And 3JS is WebGL 3D spinning stuff around, so they're kind of cool, worth checking out. Right, okay, interfaces. So quickly, we're going to talk about what kind of things you can build by considering devices in close proximity to each other and by thinking about using them together. So this is our Christmas party. Yeah. Sounds boring, but yeah, no, we're playing Pictionary at our Christmas party, and the way we were doing this is we had a browser on that projector, and with a webcam, with a marker that you could draw pictures, and like so, yeah, you could draw a line with your marker, and everyone else in the room had their own phones, which those pictures are getting streamed to. And they could also make guesses, and those guesses would appear on the top right. And what I really liked about this is, firstly, it uses this kind of technology that's designed to kind of connect the world together, but just in the same room, which is kind of, it works really well in that. And also the fact that the web really augmented our experience of the event. So we weren't thinking about we're using these phones. We were thinking we're playing Pictionary, and it's a different form, but it really kind of it was part of our kind of social interaction with each other. And then another instance of when this this approach can be useful is like, so this is Logic Pro, which is a audio editing tool, and it's got this kind of skeuomorphic like sound desk thing at the bottom, which you can slide those sliders and turn the knobs. And you do that by moving your touchpad and selecting one, clicking on it and dragging those up and down. So yeah, so that's how you interact with it. But you can get this companion app for this, which sits on an iPad. And what's nice about this is that turning knobs is a lot more intuitive on a touch device and moving dials. And also, so not only is it easier, but you can actually turn multiple knobs at the same time and slide multiple sliders. So that's actually something that's physically only possible by having this companion app and by using them together. So yeah, I think that's quite cool. This is actually like, yeah, so this is not a website, but it could be. And another example that I like is, so youtube.com. If you go to youtube.com/TV, it kind of switches into this being this more passive style interface. And you can sync up your phone and choose what videos you want to play on YouTube. And as soon as you choose them, they'll start playing on your TV or your computer. And what I like about this is that it's really intuitive to use. Like, so anyone just comes up and they're like, it becomes really natural just to choose a video on this device and have it play over there. And that's because, well, one of the reasons is it replaces an existing paradigm of how we interact with things. So it replaces a remote control. So everyone is aware of being able to pick up something and change the channel with it. And the fact that we're using web technology for not only the remote control, but also the television just fits into that, our concept of how to interact with the world. And on that note, I really like this tweet I saw, which is a little girl using a mouse for the first time, which is, yeah. And I saw someone show me this thing the other day, which is really cool, which is the little kids reading magazines, and basically to them, magazines are like broken iPads. Like they're like these things that you can't scale in or tap on. But yeah, so what I think is that with certain ways of interacting with technology, you can come full circle around. So things, you kind of try out those kind of crazy demo stuff, and it comes around to being something quite intuitive and natural for someone to use. Like, so touch devices, reaching out and touching something and moving it with your hands is a very kind of natural thing to be doing. And that's, I really want technology to get back to that sometimes. So yeah. And so this is some patterns for how a multi-device interaction can be formed. So one of the most common ones you might use is like coherence. So you've got content suited to a particular device. And so you might come across this as responsive web design. So like media queries allow you to suit content to a particular device. Someone pointed out yesterday that something really interesting about this is that the TV only has one dot in it, which, despite it being a much larger screen, and it's just the way that you, so it's not just purely based on screen size, it's based on what's appropriate for that device. Synchronization is like how you conceptually, how your data shifts between different devices. So reading on your Kindle and then going onto your phone when you're waiting at a bus stop, you should be at the same page, and that concept is keeping things in sync. And we've got screen sharing as well, which we're going to look into a bit more just now. So phone time. Right, so we had 47 devices in this room. And another thing, 48, cool. Another thing that we grabbed, as well as all those capabilities, is the size of each screen. And what we can do is we can actually view all the screen resolutions for every device in this room. So this is all 47 devices laid out. So you can see we've got like a big black phone-shaped thing here, and then a particularly big, and then the rest are kind of like laptop-y kind of things. That looks like a square one, but yeah, a lot of different screens. So with screen sharing, the way that you'd maybe generally approach this is you've got something you want to screen share, so you overlay it over all these at the same time. And that image is like sent out to everything at the same time. And but if we're considering all these devices being quite close to in close proximity to each other, we can actually approach screen sharing in a slightly different way. So what we can do is we can lay out all these into a kind of virtual space. So every device in the room occupies a particular point of this space, and then we can overlay an image over the whole of it. So you should be able to see a little part of that image on your devices. And this is Alan's laptop, and a bit of Alan top. So yeah, so you should be able to. So we're basically approaching screen sharing in quite a different way here by considering all these devices right next to each other. Cool. And what's nice is, so I can actually connect another device to this. So I'm going to connect my phone, and everything should have jiggled around slightly. And you can see that this phone is like there. And this is connected slightly differently. So all your devices are listening for these updates. But this device, I can actually touch it and move this around. So my touches get proxied across that other one. And then when I drop it, your devices should update. So I can carry on moving these around. So get a new place there. Yeah, and that works. Thanks. Cheers. More claps. Thanks. Another thing I can do is so I can visit that same page on this device. So that device is now up there. And on this new device, I can move this around in the same way, but I can also move with the old device at the same time. And yeah. Yeah, and so that's kind of a multi-touch gesture shared across 2 different devices, which kind of works quite well. And yeah, what's nice about this is it feels quite natural. It's kind of, it's what should happen, right? Like you should be able to touch this image proxied through these 2 different devices at the same time. But yeah, that's that. Nice laptop stickers. Cool. Right. So, last section, no demos. So, moving this forward, how to kind of, I want to talk quickly about how we can kind of try and embrace new types of interaction with technology and with using the web. So, the example Alex uses, this is Adventure, which is a game for the Atari video game console. And this game, the games preceding it were like Pac-Man and Pong. And in those games, the user's world within that game was confined by the screen size. So when you're playing Pong, your world within that game is this tennis court. And when you're playing Pac-Man, your world within that game is that one maze. Whereas with this game, you'd walk off the bottom, having collected that key or whatever it is. And then when you did that, you would come off back in at the top, and you'd come in the redrawn cave system part. And what's cool about this is that suddenly the user's world within that game has been hugely broadened, right? Potentially infinitely, like this cave system could go on forever. And what I really like about this is the fact that the technology hasn't changed to facilitate that. So it's built on exact same technology, the same developers wrote it, and suddenly the player's experience within that game has been broadened hugely. And bringing this to the web, and technology, there's going to be a lot of things in the future, in the next few years, that are going to be like badass, really good, and that is going to move things forward hugely. But by far, a huger thing that we can move forward is our ideas of how people can use technology and how people can interact with it, and that's the real constraint and the things that we want to push past. And I'll leave with, this is my favorite quote, I think, ever, which is, "My freedom will be so much the greater and more meaningful, the more narrowly I limit my field of action and the more I surround myself with obstacles." So this is about writing music, but it's quite relevant to web development. And what I take from this is that for us to be truly creative, you need to know your constraints, and you need to be pushing up against those, and possibly past them. And what I like to think is that you're able to choose what your constraints are. So you might choose to be constrained by trying to make something look identical in several different devices, or by trying to change some kind of data so it fits into a particular format that will work with some database better. But you can also choose for your constraints to be outside the implementation and the way that we interact with technology. And I think, that you can do some quite exciting stuff by doing that. Cool. So I'm Ben, and I work at White October and JS Ox. Whatever. Cool. Thanks.